You know them? You've seen them on pretty much every circuit board ever made. Those little black chips with all the silvery legs sticking out, they are, without a doubt, the core of all modern electronics. But what is actually going on inside of them?
Well, today, we're going to find out. We are going to peek inside that black box and really understand what makes these integrated circuits, or ICs for short, the absolute bedrock of every single device we use.
So here's our game plan. We'll kick things off with the absolute basics of what these chips are. Then, we'll look at their physical casing, the black part. After that, we're diving deep into the microscopic core, and we'll wrap it all up by exploring the incredible variety of jobs these little guys perform. Okay, let's dive right in with the most fundamental question of all. What is an IC, really? Here's the key thing to get. An IC isn't just one single component. Nope, it's an entire, complete circuit, sometimes with millions, or heck, even billions of parts like transistors and resistors, all shrunk down and integrated onto one tiny piece of silicon. And that right there is why you'll often hear them called the heart and brains of a device. Doesn't matter if it's a simple little timer or a super complex microprocessor. The IC is what's doing all the heavy lifting, all the thinking. Now here's a fun fact. When we look at an IC, we're not actually seeing the circuit itself. What we're seeing is its protective shell, which has a name, the package. In this package, it has two absolutely critical jobs. First, it protects the incredibly delicate microscopic circuit that's hiding inside. And second, it takes these impossibly small connection points and basically fans them out into those silver pins that we can actually solder or plug into a circuit. So how do you make any sense of all those pins? Well, every IC has a specific orientation, a right way up. All you have to do is look for a small dot or little notch on the package. That is always pin 1. From there, you just count your way around the chip, counter-clockwise. It's a universal system that works for pretty much all of them. Simple as that. Okay, now that we know how to read the pins, let's look at how these chips actually connect to a circuit board. Basically, all ICs fall into two big families, and it all comes down to their mounting style. On one side, you have through-hole. As the name suggests, its pins go all the way through holes in the board. This makes it bigger and, frankly, a whole lot easier for us humans to work with. On the other side is surface mount. These guys are tiny, they sit right on the surface, and they're what makes your phone so thin. But they can be a real pain to work with by hand. Now, if you're just getting started with electronics, the DIP, or dual inline package, is going to be your best friend. And here's why. The pins are spaced exactly 0.1 inches apart. That's a golden standard that lets it plug perfectly into a solderless breadboard. Super easy for prototyping.
Meanwhile, in the surface mount world, things get a little wilder. SOIC packages are kind of like tiny dips, and they're still pretty manageable to solder. Then you've got QFPs, which have pins on all four sides, getting trickier. And then you have BGA, or ball grid array. The connections are literally a grid of tiny solder balls underneath the chip. Yeah, that's master-level stuff, usually handled by robots.
All right, we've seen the outside. We've talked about how it connects to things. Now, it's time to finally look inside the black box.
What is the actual integrated circuit that the whole package is designed to protect?
This is it. This is the real magic. It's called a die. This tiny, shiny square is made of silicon that has been intricately etched and layered with other materials to create a complete, functioning circuit, all its components, all its connections, in the smallest possible form. It's like a microscopic city.
And just how complex are we talking? Well, modern microprocessors can pack billions, with a B, of individual transistors onto a die that's smaller than your fingernail. The scale is it's mind-boggling.
And looking at this, you immediately understand why that package is so important, right? The connection points on the die itself are microscopic. There's just absolutely no way to work with them by hand, which is exactly why the package exists, to translate those tiny points into larger, usable pins.
Okay, so we know what they are and how they're built. But what do they actually do? Let's kind of zoom back out now and look at the huge range of functions these chips perform.
I mean, they do everything. You've got super simple ICs that just contain a few logic gates, the most basic building blocks of digital stuff. Then you have famous single-task chips like the 555 timer. Moving up in complexity, you get the powerful brains like the microcontrollers and an Arduino. And you even have ICs that are complete sensors, built to detect everything from temperature to motion.
If you're building electronics projects, you'll probably run into these types the most. You'll have a powerful microcontroller acting as the brain, various sensors to let your project perceive the world, and then a bunch of simple logic chips to handle all the basic tasks. They all work together to bring your ideas to life.
So, there you have it. We've made the journey from a familiar little black chip to its pins and how it's mounted, all the way down to the microscopic, insanely complex silicon city that's hidden inside. It's this incredible technology that really, truly is the foundation of our entire digital world.
You know, we went from just a handful of transistors to billions on a single chip in only a few decades. It leaves you with a pretty wild question to chew on. As that density just keeps on growing, what amazing new possibilities will the next billion transistors unlock? Thanks for tuning in.